Hello students, welcome to the module on trigonometry. In this video, we'll discuss the wrapping function. We will draw the unit circle, x squared plus y squared equals 1, which is the set of points one unit away from the origin. So to construct the wrapping function, we will first plot the unit circle. Here's the x-axis, here's the y-axis, and here is the unit circle. And some common points on the unit circles, this point over here is the point 1, 0. This point over here is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. And there are many other points in the unit circle as well, infinitely many in fact. What we will now do is we will now draw a line tangent to the unit circle at the point 1, 0. And on this pink axis, I will call this value 0, and I will call the pink axis the theta axis. As I go above the x-axis, we will have positive values of theta. As I go below the theta axis, I will have negative values of theta. So the line that's tangent to the unit circle at x equals 1 is the theta axis. What I will do now is I will define the wrapping function. Define omega of theta, the wrapping function, as follows. If theta is positive, we will draw the interval on the theta axis all the way up to theta. So this interval over here on the theta axis will be the interval 0 to theta. So we will, for theta greater than 0, we will wrap the interval 0 theta onto the unit circle counterclockwise. So if theta is positive, I will take this interval 0 to theta on the theta axis, and I will wrap it around the unit circle, and I will end at a point xy. So omega of theta in this case will be the point xy. If theta is less than 0, we will wrap theta 0 onto the unit circle. This time we'll wrap it around clockwise. So I will take the interval, if theta is negative, I will wrap around in a clockwise fashion and equally well get to a point xy. And the wrapping function will be, in this case, the same thing. Omega of theta will just be the point xy on the unit circle that you get when you wrap the function around. So for example, we know that the circumference of the unit circle is 2 pi. So if I looked at the wrapping function of 2 pi, I would plot an interval of length 2 pi and wrap it completely around the unit circle and get back to where I started. So the wrapping function of 2 pi will get back to the point 1, 0. The wrapping function of the point pi, well, pi is half the unit circle, so if I take an interval of length pi and wrap it around, I'll be exactly halfway across, and this will be the point -1, 0. If I did, for example, the wrapping function of pi over 2, that would be 1/4 of the circle. So if I took pi over 2 and wrapped it around, I get 1/4 of the way around the circle, and that would end at the point 0, 1. In further videos, we'll do more examples and see how we can plot the wrapping function and graph it using the unit circle. Thank you very much.